The quadcopter is 600 meters high. A conventional descent would take at least 3 minutes. How can we get down as quickly as possible, and all of this automatically? Why does conventional descending take so long? During hover, climb, and slow descent, the rotor draws the airflow cleanly from top to bottom. During faster descent, the rotor flies into its own downdraft. This is the vortex ring state, which is unsteady and can lead to a loss of control. This is the normal working state. This is the onset of the vortex ring state. The vortex ring state can be avoided if the copter flies sideways. A common approach is to have the copter descend in a spiral. However, that's still not particularly fast. We want the copter to descend in free fall while tilted 90 degrees forward. That's why we call this flight mode dive mode. The attitude controller is active during this maneuver and maintains a constant flight attitude. The dive mode continuously evaluates when it's time to exit the free fall. For dive recovery, the copter flies a circular arc, with the airflow coming only from the side again. An attitude controller with a thrust controller is used for this stage. Next comes the horizontal deceleration phase. This takes place in altitude hold flight mode, while maintaining a slight pitch angle. Finally, the autopilot switches to loiter flight mode and the copter comes to a stop. Since the dive mode is based on existing controller modules, it is very easy to parameterize. We developed the dive mode in a simulation using MATLAB Simulink. We have implemented the dive mode in the Multicopter autopilot, which uses the control method incremental nonlinear dynamic inversion. Multicopter is integrated into the ArduPilot autopilot as an additional flight mode. For testing, we used a Holybro S500 quadcopter. It weighs 1.5 kilograms and has 10-inch propellers. To ascend, we used the loiter flight mode, in which the pilot controls the speed using the control sticks. The dive mode is activated via a switch and then runs completely automatically. The copter reaches its top speed of 30 meters per second after about 8 seconds. The entire maneuver takes just under 30 seconds, which is 6 times faster than a conventional descent. The dive mode not only allows copters to fly even higher thanks to the energy savings, but also serves as a safety feature in case a rapid descent is necessary due to approaching manned aircraft. Thanks for watching.